Hello, dear friends. Today is a time to study, enjoy a lecture related to the electrostatics and electric charges. With the help of this lecture, I would like to make you familiar related to the charge and the process or the branch, one of the branch of the physics that is called electrostatics. So let us start, dear friend, electrostatics. It is quite clear if we just differentiate this word electro and statics. Means this particular branch of physics which deals all the study related to the charge and rest. Means in this whole branch, in this whole study, our charges will not get into the motion. So as far as its definition, that branch of physics which deals with the study belonging to the stationary charges are called as electrostatics or static electricity. So in this definition, one thing is coming, that is charge. Charge has been already introduced in your small classes, but let us go technically with the charge. Charge we call the electric charge. Okay, and this was discovered around 600 BC by a Greek philosopher Thales of Miletus. He was rubbing the amber material over the cat skin, and when he brought the amber rod near the paper pieces, he found that those paper pieces was get attracted towards the amber. That was the event which initiated, which was responsible for identifications or the discovery of electric charge. If we just go for a concrete and clear definition for the electric charge, so it can be defined as it is that physical quantity due to which object exerts electrostatic force and respond to the electric field. Means this particular property gained by the object will start showing the electrostatic force of attraction, repulsion, depends on the nature of charges, which we are just going to discuss, and also response in the electric field. If we divide the charges, it was found the charges are of two types. One is a positive charge and another one is a negative charge. So let us highlight it more for your convenience, so that you can easily see it. Okay. So this is positive charge and negative charges. The old name of this positive and negative charge, positive charge was known as vitreous and negative charge was known as resonance. When we study about the frictional electricity, then we will discuss that how or which material requires what type of charges. It is highlighted more. I think it is quite visible to you people that glass rod, woolen cloth, cotton, cat skin, woolen carpet, these will acquire the positive charge when they rub over a silk, amber rod, ebonite rod, rubber suit and plastic object. During the friction, these materials will acquire the positive and these materials will acquire the negative charges. Now, it is quite difficult what is positive charge, what is negative charge. So, related to the charges, three theories was given related to the electric charge. How a neutral body will get charged, what was the reason behind it. So there was three different proposed by different scientists. So the theory which comes in a very first movement, that is called Franklin's one fluid theory. The theory comes next, that is called Simon's two fluid theory, and the third one, which is most acceptable and existing so far, that is called electronic theory. So one by one we just discuss. I would like to introduce all these theories. One is the Franklin's one fluid theory. So this Franklin's one fluid theory, in this Franklin's one fluid theory, he considered that there is a certain kind of fluid present in every body, but due to any way, if that particular individual fluid transferred from one body to another body, then the body which gains or which receives that kind of fluid from another body will get positively charged, and the body which donates the fluid, that becomes negatively charged. But the matter arises that when a body is in neutral state, it also contains that particular kind of fluid. So how to describe the electrical neutrality of an object which already contains that particular kind of fluid? So this was the reason due to which it was unacceptable, and very next to it, the next theory comes into the play, that is called Simon's two fluid theory. He easily explains that no, there is not a single kind of fluid in a body in neutral state. There are two different kind of fluid. In a body in neutral state, the kind of fluid will be of equal amount. One we call as a positive fluid, another we call as a negative fluid. So if due to the interaction, positive kind of fluid transfer to another body, then what happens? The next body will have more positive fluid, so it becomes positively charged. And the body which donates that positive fluid will have less amount of, comparatively less amount of negative fluid, positive fluid, so it becomes negatively charged. If negative fluid is going to transfer to the next body, the next body will have a negative kind of charge, negatively charged. So due to imbalancing between the positive and negative fluid, the bodies will either get positively charged or get negatively charged. So it was acceptable at very starting moment. But what happens? With the study progress, there was no such kind of fluid was detected. So it was also rejected. Now, next to it, another theory comes into the play, that is called electronic theory. In this electronic theory, very acceptable, as we know there are protons present in a body, and electrons are in the outermost orbit, so it can be easily transferred from one body to another body comparatively. So as far as electronic theory, if a body donates the electron to another body, then the body which receives the electron from another body, it will have the inequality in number of protons and electrons in the body. The number of electron in it becomes more than the number of proton as compared to its neutral state. So it becomes negatively charged. And the body which donates the electron, it will have less number of electron as compared to the proton during its neutral state. So it becomes slightly positive charge. And the exchange of electron will take place in an integral multiple of charge on one electron. So this is the electronic theory, and it is mostly acceptable, and we follow it there. So now we all are familiar how a body will get positively or negatively charged. Now next step which we should do, that we must study about the properties of charges or the body which is get charged. So there are several properties, we will discuss one by one. One is the property of attraction and repulsion. As far as this property, attraction and repulsion, like charges will repel to each other and unlike charges will attract to each other. It means if there is a positive charge body and negative charge body, then there will be attraction between them, and if there are two positively charged bodies or two negatively charged bodies, there will be repulsion between them. So this is the first property, and the next one is called as quantization. This is a quantization. Quantization means presenting in the form of discrete value. So charges are quantized in nature. It means that total charge on a body is integral multiple of charge on one electron. It means that always whatever be the charge on a body, that must be integral multiple of the charge on one particular electron. Mathematically, this quantization of charge can be represented by this equation. That is, Q is equal to plus minus Ne. Here, you see, Q is equal to plus minus Ne. What is N? N is any integer 0, 1, 2, 3, positive or negative. And E is the magnitude of the charge present on one electron, and the magnitude of the charge present on one electron is 1.6 into 10 raised to power minus 19 coulomb. Now, coulomb is a unit to measure the charge, as it is a physical quantity, so every physical quantity must have a unit, and coulomb is a unit for measuring the charge, and we will discuss and define it later. Now, we move to the very next property, and that is called conservation. Conservation of the charges. Conservation, there are different conservation laws, conservation of momentum, linear momentum, angular momentum, conservation of energy. In the same manner, it also the conservation of charge means charges are conserved in nature. It neither be created nor be destroyed. As you know, as far as the electronic theory, the charge developed due to the exchange of electron, transformation of electron from one body to another body. So either electron moves from one body to another, or another second body to the first body. So charges are always conserved, neither be created nor be destroyed. And there are certain equations in terms of that. We may just give some examples of conservation of charges. Here, this equation is called as this process is called as pair production, where here gamma photons, this breaks into the electron and the positron. The total charge at left hand side is 0, and total charge at right hand side also 0. It means this shows the conservation law. Now the next process is also when positron and electron annihilate, then it produces two gamma protons, and in this process also at left hand side the net charge will be 0, and at right hand side the net charge will be 0. So this process also shows the law of conservation of charge. In this process also, in radioactive process, uranium breaks into thorium and helium, and here also if you just apply the net charge present at left hand side and the net charge present at right hand side, you will just get that this is equal and it follows the law of conservation of charge. Now the very next property, that is called additive in nature. Make it visible for you. This is additive in nature. Additive in nature means the net charge on a body will be equal to the sum of the charges present on the body. Additive in nature. nature. Charges are additive in nature, that is total charge on a body is equal to the sum of the charge on each part of the body. Just like in an atom, protons are present at the nucleus and electrons revolving around the nucleus in a different orbit. So the electrons are at different place, protons positive charges are at different place, but atom is neutral. It means the net charge is equal to the sum of the protons and sum of the electron charge on the electron. So total charge on a body is equal to the sum of the charges present on each part of the body. This is called additive nature of the charge. Now we move to the next property, that is called invariance. Invariance means not vary. In effect, unaffected by the velocity. Charge on any body will not get affected by its speed or its velocity. This nature of charge is called as invariance nature. So charges are invariance in nature, that is charge on a body will not be affected by its speed. It means whether it is in rest, whatever the charge on a body, the same quantity of the charge on a body will remain when it starts moving either slow or very fast. So this nature is considered to be the invariance nature of the charge. So these are the main property of the charges. As we described, the charge is one of the physical quantity. So it must have a unit, and the unit of charge is coulomb. There are several other units, like 1 coulomb is equal to 3 into 10 raised power 8 stat coulomb. This is ESU unit. 1 EMU is equal to 10 coulomb. So there are different units which is used for measuring the charge of a body. Then every body, every quantity is having its unit, its dimensional formula. So here in the case of charge, its dimensional formula is AP. A is the dimensional formula of current, P is the dimensional formula for the time. So dimensional formula for the charge is AP. And let us define 1 coulomb. This is a unit for measuring the charge. So we may define 1 coulomb with the help of an equation, that is called the equation of quantization of the charge. You know that Q is equal to plus minus NE. And if Q is going to be 1 coulomb, then N into E 1.6 into 10 raised power minus 90. It means N will be equal to 1 upon 1.6 into 10 raised power minus 90. Then taking this decimal out, here it becomes 10. Then 10 upon 60 into 10 raised power minus 9. This will be N is equal to 6.25 into 10 raised power 18. It means that 1 coulomb is the charge developed due to the exchange of these many electrons, either going out or coming into the body, means 6.25 into 10 raised power 18. So 1 coulomb is the charge developed on a body due to transfer of 6.25 into 10 raised power 18 electrons. So now I hope that you must enjoy this lecture, and it provides you the clear-cut, exact informations and text for your further study, and there will be no confusion, and also it is a clear presentation, so it also saves your times and helps to involve that particular time for the further study, and more topics you may cover in a less interval of time. So keep watching this website www.global